Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of continuity. So as per the problem, find the values of x at which each function is discontinuous. So first let's go over the concept of continuity. So continuity means that there is no break in the graph of a function. So there are three types of breaks possible in a graph. So there can be a jump, a hole, or a vertical asymptote. Now in this problem, we have to find the x values at which each function is discontinuous. So that means we have to find the x values at which there is a jump, a hole, or a vertical asymptote in these given functions. So let's start with part A. So in part A, we are given a rational function. So the first step is to factor this rational function as much as possible. So in this case, we can factor the numerator. So we can factor the numerator using the difference of squares factoring method. So we know 9 is a perfect square, so we can rewrite this as 3 square minus x square over x minus 3. And now we can break up the numerator expression. So we get 3 plus x times 3 minus x over x minus 3. Now, and the expression in the numerator 3 minus x can be written as x minus 3, which is in the denominator, if we factor out a negative sign from that parentheses. So we get f at x equals negative. So then 3 plus x. So the first parenthesis stays the same. Then x minus 3 over x minus 3. So we can cancel out the x minus 3 from the numerator and the denominator. So that means there is a hole at x equals 3. So we sub x minus 3 equal to 0 and then solve for x, which is equal to 3. So in this case, there is a hole at x equals 3 because x minus 3 is the common factor in the numerator and denominator. So this function is discontinuous at x equals 3 because there is a hole. So now we can analyze part B. So part B is another rational function. This function cannot be factored and there is an x in the denominator. In this case, there is a vertical asymptote. And to find the vertical asymptote, set the denominator equal to 0. So we get x equals 0. So in this case, there is a vertical asymptote at x equals 0. So this is where this function is discontinuous. So now we can analyze part C. So part C is another rational function. Now we cannot factor this expression in the numerator or the denominator. So in this case, there is a vertical asymptote. So for that, we'll set the denominator equal to 0. So we say x cubed equals 0. And now we can solve for x by applying cube root to both sides. So on the left side, the cube and the cube root cancel each other out. So we get x equals, and the cube root of 0 is 0. So that means there is a vertical asymptote at x equals 0. So that's where this function is discontinuous. So now we can analyze part D. So part D is another rational function. We can factor this expression. We can factor the denominator of this expression using the difference of squares method. So the numerator will stay as it is because we cannot factor it. Now in the denominator, we know 9 is a perfect square. So we can rewrite this as 3 square. And in the next step, we can break it up using the difference of squares method. So in the denominator, we get x plus 3 times x minus 3. Now in this case we cannot cancel out any of these factors, so that means there are two vertical asymptotes in this rational function. So for the first one, we'll set the first factor equal to 0 and solve for x, which is we get x equals negative 3. So this is the first point of discontinuity in this function. And now we'll set the other factor equal to 0 and solve for x. So if we add 3 to both sides, so we get x equals 3. So this is the second point of discontinuity in this function. So there are two vertical asymptotes in this function, so that's why there are 2 points of discontinuity. Now we can analyze part E. Now part E is another rational function, so we should first factor the expression as much as possible. So in this case, we cannot factor the numerator, but we can factor the denominator because the denominator has a simple trinomial expression. So we have to find two numbers that add to 1, which is the coefficient of the x term, and the product of the two numbers should be negative 6. So the numbers are 3 and negative 2, because the sum of 3 and negative 2 is 1 and then the product is negative 6. So we can rewrite this function as g at x equals 13x over x plus 3 times x minus 2. Now we cannot cancel out any of the factors in the denominator, so this function has two vertical asymptotes. So for the first asymptote, we'll set the first factor equal to 0 and solve for x, so we get x equals negative 3. So this is our first point of discontinuity in this function. And for the second one, we set the second factor equal to 0 and we get x equals 2. So this is the second point of discontinuity in this function. So this function has 2 points of discontinuity. So now we have to analyze the last one, part f. We are given a piecewise function. So here the function is broken up at x equals 3. So for the left side of 3 and including 3, the equation is negative x, and for the right side of 3, the equation is 1 minus x. Now for continuity of this function, we have to use limits and check whether the left hand limit is equal to the right hand limit at x equals 3. So let's start with the left hand limit. So limit x approaches 3 from the left side, and for that the equation we'll use is negative x, because that's the equation for the function when x is less than or equal to 3. So we sub in x as 3 in this expression, so we get minus negative 3, which is equal to 3. So this is the value of the left hand limit. So now we'll analyze the right hand limit. So 3 on the positive side, and for that we'll use 1 minus x. So we'll evaluate this limit by subbing in x as 3. So we get 1 minus 3, which is equal to negative 2. Now in this case, the left hand limit is not equal to the right hand limit. So that means this function is discontinuous at x equals 3. So in this case, there is one x value at which the function is discontinuous. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.